Okay, here's the solutions for our integration problems. We had rows A through E, and there was 4 problems in each row. Remember, the first thing you had to look at was whether or not you could first do either some algebra or trig, and then consider whether or not you had to do substitution. I'm going to do row A first. So in row A, the first problem could be done without any algebraic manipulation or substitution. Straightforward indefinite integral using the rule x to the nth, and the answer is 1/4 x to the 4th plus x plus c. Remember, these are all indefinite integrals, so let's remember that plus c. The second problem in that row required substitution. It is the composite function where we have the x cubed plus 1 inside that power of 4. So we're going to let u equal the x cubed plus 1. Then we take the derivative of whatever we set as our u, and that gives us 3x squared dx. Now when we go back to our original problem and try to rewrite it, we have this extra factor of 3 with the x squared dx, so we write it as 1/3 du equals x squared dx. So now we rewrite our original problem, and remember we haven't integrated yet, so I have u to the 4th. That's that replacement. X squared dx is getting replaced with a 1/3, which I'm going to bring out front, du. So now the answer is just 1/3 times the integration of u to the 4th, which would be u to the 5th over 5 plus c. Last step, undo my substitution, so replace u back with x cubed plus 1, so I end up with 1/15 x cubed plus 1 to the 5th plus c. The next problem in that set was the one that couldn't be done. When we try to do the substitution, just let me show you for that one. It's x cubed plus 1 dx. Really, the only substitution you could think of here would be x cubed plus 1. Well, when we take that derivative, we end up with that 3x squared extra. There's no replacement for 3x squared. Actually, it's 3 that's not the problem, it's just the x squared. So this is one that we can't do. Okay, now for row B. The first problem was one in which we just had to do some algebra and then we could integrate. We don't need to use substitution. Oops, that's an x. All right, so we think of this as x to the 1/2, and then we just distribute. So this original problem can be rewritten as x to the 1/2 minus x to the 5/2. And then we just integrate each part. So we end up with 2/3 x to the 3/2 minus 2/7 x to the 7/2 plus c. That second problem was one that you couldn't do. Again, that same problem we end up with, if we try to let u equal 1 minus x squared, we end up with the du of negative 2x, and there's no replacement for the negative 2x. The next one, 1 over the square root of 1 minus x squared. Another one we can't do. So in this row B, we only had 2 problems we could do. That last one, we're going to let u equal the 1 minus x squared. And then du will be negative 2x dx. Well, we only need an x dx, so we make that negative 1/2 du equals x dx. So now we rewrite this, and this is 1 over that square root, so it's going to be u to the negative 1/2. And then I'm integrating that coefficient of negative 1/2, and then I'm replacing x dx with du. So now I integrate, and I end up with negative 1/2 times 2 u to the 1/2 plus c. This will make negative 1. So it's going to be negative. I'm going to rewrite this in radical form. So it's the opposite of the square root of 1 minus x squared plus c. All right, column C. The first problem is one that can't be done. You try, well, first there is no trig identity, no algebra, so you try letting u equal different things, and none of the substitutions work because you always end up with either an extra cosine squared or an extra sine. Okay, the next one can be done real simply if we remember our trig identities, specifically the Pythagorean identity. Remember, sine squared x plus cosine squared x equals 1. So 1 minus cosine squared is equivalent to sine squared. So I'm going to rewrite that original problem like that. Square root of a square, they cancel, so this turns into the simple problem of integrating sine. The integration of sine is the opposite of cosine. It's right on your formula sheet. Done. The third problem in that row is also very simple, using another trig identity. This is 1 over cosine squared. Well, 1 over cosine is secant, so 1 over cosine squared is secant squared. So I'm going to rewrite this These are equivalent problems. The integration of secant squared is tangent x. And the fourth problem in row C is one that cannot be done. Okay, on to row D. The integration of tangent x, secant x. Look on you, this is one of your formulas on your sheet. The answer to that is secant x. And remember, we're just going backwards. The derivative of secant x is secant tangent. Right, the second one, here I do have to do some trig work here. I need to rewrite tangent. Remember, is sine over cosine. So this will make 1, so this turns into just the integration of sine x again, which will be the opposite of cosine x plus c. All right, the third one in row D. Remember, our general rule is to let u be the base of any power. Usually works, not always. Well, here we have two powers. We have tangent x really to the negative 1/2, and then we have secant x squared. So here we need to think about derivatives. Well, remember, the derivative of tangent is secant squared, so that's what you want to let your u be. So now we can rewrite this original problem. It's u to the negative 1/2. And secant squared dx becomes our du. So we integrate u to the negative 1/2, and we're going to get 2u to the 1/2 plus c. Take out my u, and I'm going to get 2 square root of tangent x plus c. The fourth problem in that set cannot be done. Right, if it were just over tangent, we could rewrite that as cotangent, but because we have that +1, there's no way to rewrite this. It's not an identity because the tangent isn't squared. Substitution will not work because if we let u equal tangent x plus 1, its derivative would be secant squared, which we don't have in this problem. So can't do that one. All right, last row, which is E. We have the integration of e to the negative x squared. For this one, we remember the integration of e to the u is just e to the u. But here, our u, which is negative x squared, would have a derivative of negative 2x. Well, we don't have that negative, the negative 2 is in the problem, we don't have that x in here. So this one is a can't do. Go to the second one in row E. And this one we can do. Here we let u equal 3 plus e to the x. And the reason we want to let u be that denominator is because we want to put that to a power of negative 1. So du, derivative of 3 is 0. Derivative of e to the x is e to the x. So now this becomes 1 over u, and then e to the x dx is my du. Remember, the integral of 1 over u is the natural log of u. So this will equal the natural log. I'm going to take the u out, put the 3 plus e to the x back in, and remember my plus c. Okay, the third one in row E. This one we can do without any algebra or substitution. Basically, we're just going to integrate each part, e to the x, and then integrate 3. The integral of e to the x is e to the x, plus the integral of 3 is 3x, and then plus c. The last one in that row can't be done right now. And that should be it.